Unit 3 is going to be about graphs, rules, and patterns. And I want to start with stories from graphs. Graphs are a really good way to show a visual picture of what's actually happening. And if you're aware of what a graph can represent, then you can start to pull the story out of the graph. So if we look at this first example, it's a graph of battle robots, and this is what we call a scatter graph. And that's just because it's basically big points. And I know those don't look like points, but they're kind of giving you a picture of it. But you can imagine that this bird robot is on that point, and the dog robot is on this point. The purple robot is maybe on this point. The flying shark robot on that point. And this stumpy little legged guy maybe on this point down here. So this particular graph is going to tell us a story about the range, or how far these can travel. So how far they travel, and the speed, which is of course how fast. So kind of important stuff about robots, to know how far can they travel and how fast can they go there. And if we look at this, we can start to pull out some information. So I might want to ask, what do we know about the bird robot compared to everybody else? How far can it travel? Well, if we go out along this axis, we notice that it can travel 500 kilometers. So its range is 500 kilometers. And the speed with which it can travel is 240 kilometers per second. That's super fast. So the speed is 240 kilometers per second. And that is of just the little bird robot here. Okay. Now compared to, let's say, the shark robot, who's faster? Well, you'll notice that the shark robot only travels at a speed of 160 kilometers per hour, and the bird robot travels at a speed of 240. So the bird robot is actually faster because it's further up. So the further up the graph you are, the faster you're going. And the further along this axis, the further you can travel. So we'll notice the slowest robot with the shortest amount of distance is this guy here. So this one here is slowest and also shortest distance. So besides the bird robot, who can travel the next farthest distance? Well, if we think about that, the bird robot is all the way out here. So we just start moving back in time along this axis, sorry, not in time, but back along the range axis. We'll notice the next one we come across is the dog robot. So the dog robot can actually travel a distance of 400 kilometers. And that is the next largest next to the bird robot here at 500 kilometers. So again, to figure out how far these things go and how fast they travel, you can just track down. So the dog is again going to be a range of 400 kilometers. And the speed for this guy, we track along to the speed axis, we see that he travels at 100 kilometers per second. So from this graph we can get an idea of which robots are faster than each other, which robots travel further than each other, and which robots are similar to one another. I might notice that the purple robot and this guy actually travel similar in speed, a difference of 60 and 40, so they're not too dissimilar. But this bird robot is definitely the fastest and travels the furthest. So that's the idea we get. If you wanted to know about robots that you were trying to purchase, you needed to know if they could move fast or slow. For different situations, you'd be able to figure that out from this graph. If we look at another example, it's common that we'll look at distance-time graphs. So you'll notice here that's exactly what this is, a distance and a time graph. So along the bottom, we've got the amount of seconds that has passed, and along the y-axis here, we've got the distance traveled. And we've got two different athletes that we're comparing here. We've got the green athlete and the red athlete, and this is how their distance time graph travels. And here they're running a race. If we look at the graph, can you maybe figure out how far the race is? What do you think? I'll give you a hint. It's a 100-meter race, and we'll talk about what this graph tells us. So they're running a 100-meter race. Okay, so what we're saying is that at the start, this is when the gun goes off. Bam! The gun goes off and they start running. And again, the one who's furthest up the axes is closest to the finish line. So at the start here, we might notice that the green athlete is further along. It's closer to the finish line than the red athlete. He's going super fast up that line. So he's traveling in time very, very quickly. And the red athlete is also traveling in time quickly, and he's making his way. So he starts at a distance of 100 from the finish line. And then he's moved 10 meters from the start and is now at only a distance of 90, and we can see his distance is constantly increasing. He's constantly moving up the graph. But we'll notice again that the green athlete here has the lead the whole time. But this is strange. What do you think happens at this point here? The green athlete is winning. He's ahead. So for this whole section through here, the green is winning. And I can tell that because it's further along on the distance time graph. So the further up you are on the line compared to the red one, you'll notice he's above the red line here the whole time, the closer he is to the finish. But at 50 meters, what do you think happens to him? You'll notice that he hits 50 meters just after 3 seconds has passed. Come look along down to the bottom, it's just after 3 seconds. But he hits the 50-meter mark, and what's he doing this whole time? What's happening? He's staying 50 meters from the start the whole time, all the way up until 8 seconds. So that's almost 5 seconds where he doesn't even move. So the green one here is actually not even moving. We can see that because it's the flat line. He's staying at the same distance, 50 meters from the start, the whole time along there. And what happens here? What's this important point? We'll notice that the green athlete here is always above the red one, but at that particular point, who gets the lead now? Who breaks ahead? We notice that it's the red athlete now that is winning, because he is getting closer to the finish line. He's now 60 meters from the start, and then 70 meters from the start roughly, and he's carrying on. So the green athlete, maybe they were running so fast they tripped, they fell, and they fell over, and they were laying on the ground for a few seconds while they tried to get back to their feet. And in their shame for having tripped in a race, they get it together again after about 8 seconds here, and they start to run again. So the green starts running again. So he takes off running, but meanwhile, the red's been running slow and steady the whole time, nice and steady pace, still moving, still moving, still moving. And here, at this point, they've actually won the race. They've traveled to the 100-meter mark. And you'll notice here that the line starts to trail off and not as steep. And so what happens when you finish the 100-meter mark? You don't just stop instantly, but you kind of slow down for a little while, you kind of run it out for a little while, and then you come to a stop. So it's up here where you see him level off that the red athlete actually has stopped now. Meanwhile, the green athlete is running and trying to catch up, knows he's not going to win the race anymore, but just for his own pride wants to actually finish it. So here he reaches the 100-meter mark and he finishes. And then he's slowly down and probably comes to a stop up here. So from this distance time graph, I can see this whole story, that the green athlete was really fast at the start. They fell over. The red athlete passes them by at that point, goes on to wins the race, but the green athlete does get up, gets back on its feet, and runs after him and does finish the race, although a lot of seconds later. So the green athlete finishes at 15 seconds if you track down, And the red athlete finishes just after 9 seconds. So you can see there's a pretty big margin for the win there. But good job for the green athlete to get up off his feet, or get up off the ground and finish the race anyways. So his distant time graph, give you a few keys here. Steeper line is fast, and a shallow line, like so, is slow. And a horizontal line, I'll put that here, stopped. You're not moving if you have a flat line. So this guy is not moving at all when you see a flat line. So again, the steeper the line, the further up it's pointing, the faster you're going. So in this part, the green is really, really fast right here, faster than the red because it's steeper than the red. Here the green again is flat, so it's not moving. And here, looking at the red, it's running fast the whole time, and you notice as soon as he goes to the finish line, he slows down, and then he comes to a stop. So we can see that with the steepness of these graphs as well.